Okay, good afternoon to everyone. So, our next problem today is about impulse and momentum. So, would like to present you a problem that would help you in your as part of your revision for the coming exam. So, this impulse and momentum problem is like so you have here a 120 kilogram rocket moving at a speed of 9 meter per second. That's 120 kilograms. And then so this is it. uh, this one, 120 kilograms. It is moving at the speed of 9 meter per second, and there and then it explodes into four pieces, two of which 25 kilograms, and the other one is also the same 25, but the velocity, this one is 12 meter per second, and the other one is 8 meter per second. Now there's a third piece because it explodes to like four parts. There's one piece which is going at the right angles to the original line. So this is okay. If this original line, this right angle 90 degrees, that is going up with a speed of 4 meter per second. The mass here is 30 kilograms. So if you see here, this one is 30, and then you have your 25 and 25 is 50, so that is 80, right? So meaning a total of 120, so therefore the fourth piece is equal to 40. You have 40 and 80 becomes 120. So the question is to compute the speed and then the direction of this fourth piece. Okay, and estimate the energy of explosion. So first we're going to we already have the mass here. Just have to compute where is the velocity, or where's the direction of the velocity. We can assume, okay, maybe going here. Our assumption is the horizontal component of Vx is left, or Vy is going down. We'll see in our calculation if our directions if our direction of the velocity is correct. So let us try. So for example, this is our assumption. Then we sum up the momentum before, okay, before the explosion, and then equals to after the explosion. So by the conservation of momentum, law of conservation of momentum, that according to the law, that the conservation of momentum would remain the same all throughout, not unless there is an external force that causing the explosion, or that causes the changes in the momentum. So there is an external force, or probably that's caused due to impulse. Okay, at a certain particular time there is a force. So it is just like you have here 120, before is 120, and then you have 9. Okay? This one is before the explosion, and then you have here, we sum up first vertical direction. You have 25 and 12, and then you have 25 and then 8. Okay, and then we can subtract this Vx because our assumption is to the left. We can say minus 40 times Vx. You can do like that, or you can also do like this. Okay, we'll have this answer, negative 14.5 meter per second. In other words, that our assumption is to the left, meaning our true direction should be going to the right. Okay, because our value is negative, meaning that our assumption is not correct. So how about Vy? So Vy, there are only two directions. Okay, going up and then going down. Okay, so going up here, before explosion there's no vertical component. So after explosion you have 30 times 4. Okay, this is 30 times 4, and this is Vy going down, minus 40 times Vy. So we have Vy is 3 meter per second. In other words, that our assumption is correct. This one is going down. Okay, this is correct. So the velocity most likely for the third component, let us say, or fourth component, let us say v4, should be going here. So it's easy now to calculate because you have here, okay, this one is, okay, like how much is that? 14.5, and then this one is 3, okay, meter per second, and then this also meter per second. So you have here will be your component. Okay, this component, hypotenuse, the fourth velocity. Okay, by Pythagorean theorem, it is just, okay, in a triangle. If you remember, okay, this is, let us say V, or let us see A B. You have C squared is equal to AS squared plus B squared. That is the Pythagorean theorem. So our C here is V. Squared could be written in this manner. So 14.5 x component and then the y component. So you get this value of 14.81. Now how about our theta? Our theta here, say this one. Okay, tangent theta is opposite. Opposite is equal to Vy and then adjacent Vx. So we have theta is inverse tangent okay, Vx, Vy over Vx. That's why we have this one. So we got an angle 11.68, 94 degrees. For example, if you would like to measure the angle coming here, going here, of course that is just, let us say this one is alpha. So alpha will just be, that is coming from x, would just like 360 minus 11.68. Okay, you'll get this answer, 68 or 69. So you will have 348.31. Anyway, whether your answer is this one or this, these are all correct. Now, how about the energy of explosion? The energy of explosion is just the kinetic energy. Okay, the summation of kinetic energy, that is after impact minus before, after explosion or before explosion. So this one is the first piece. What's the formula of kinetic energy? 1/2 mv squared. We can just factor out 1/2, so this is mv squared. So let's say number one, then this one number two, and so on and so forth. This is number 3, this is number 4, and then this one is minus, that is because this one is before explosion. Before explosion, we have this one, 120 is our mass, and the velocity is 9 meters per second. Okay, so this is before explosion. Now using your calculator, you can have this value. It's actually Newton meter. Okay, Newton meter is equal to joules. Okay, so that's all, and thank you.